Okay, let's unpack this.
Mhm.
We are diving into a field that feels like a blend of um, cutting-edge biology, massive venture capital, and honestly, a touch of science fiction. The quest for human longevity.
It's a huge topic.
It's utterly exploded. I mean, this is no longer some fringe goal, right? It's the new frontier, heavily backed by celebrity investors, major pharmaceutical players, and, well, venture capital funds are pouring billions into solutions that promise radical life extension.
Or at least strongly imply it.
Exactly. And our mission today is absolutely critical for you, our listener, because the sheer volume of buzz, of marketing hype surrounding this industry is just, it's overwhelming.
A lot of noise.
A lot of noise. So we're here to give you a shortcut to being well-informed. Our goal is to surgically separate the genuine foundational science, what we'll call geroscience, from the pure market-driven spectacle, which is often labeled biohacking.
Right.
We need to cut through that noise, understand the core biology, look at the controversial figures pushing the boundaries of ethics and safety, and really confront the societal realities we're facing.
Yeah, and to start, we have to get the most fundamental distinction right.
Yes, this is the one that dictates where all those billions of dollars actually go.
Yeah.
We need to clarify the real objective here. Are we talking about living longer, just extending the total lifespan, or are we talking about living well longer, maximizing our health span?
And that's the key.
It is, because experts across the board warn that a huge majority of the anti-aging industry's money is funneled into products and services focused on lifespan, often with, minimal evidence.
When the entire scientific consensus should be fixed on maximizing that health span, the period of your life where you're free from disease and disability.
That distinction is paramount, because if we confuse lifespan with health span, we miss the entire ethical and scientific point of this whole endeavor.
Exactly. So, to proceed clearly, we need to establish some precise definitions from our source material. Let's start with the target itself, aging.
Good.
Our sources define biological aging as a systemic, stochastic process.
Stochastic, so random.
Mhm.
Probabilistic.
Yeah, that's a good way to put it. It's a process that happens systematically after an organism reaches reproductive maturity. And its essence is really the escalating loss of molecular fidelity within our cells.
Molecular fidelity.
Basically, the complex, highly ordered systems in our bodies. They start making tiny, accumulating errors, and eventually those errors exceed the body's innate capacity to repair them.
So we just can't keep up with the repairs.
We can't. And this failure to maintain that perfect molecular order, it dramatically increases our vulnerability to all those age-associated diseases. It's an unavoidable, cumulative molecular mess, really.
Okay, so if aging is the mess, how do we define the organized effort to try and clean it up?
Well, that brings us to geroscience. This is the legitimate scientific response.
Okay.
Geroscience is the comprehensive understanding of those complex processes underpinning biological aging. And it's specifically with the aim of intervening in those deep underlying mechanisms.
So it's not just treating symptoms.
Exactly. The goal isn't just to treat, say, cancer or heart disease one by one as they pop up. It's to tackle the common root cause, aging itself. And this field has, transformed dramatically. It's shifted from what was once seen as a kind of speculative, soft branch of biology into a hard, evidence-based science.
Right, thanks to modern tools like genomics and molecular research.
That's right.
And finally, the term that just dominates the headlines and, the Instagram feeds, biohacking.
Biohacking, as it's defined in our sources, this is a fundamentally different approach. It's characterized as do-it-yourself or DIY biology.
The DIY part sounds a little scary when you're talking about biology.
It can be. It involves individuals using various combinations of, science, technology, extreme diets, and lifestyle changes to try and enhance physical function and longevity.
But the key difference is
Right.
the evidence.
The evidence. The critical defining caveat here is that biohacking often operates outside of peer-reviewed consensus. It frequently lacks robust scientific evidence, and it's consistently characterized by professional medical experts as non-professional.
And dangerous, I'd imagine.
Some sources warn that these self-experiments carry what they actually term atrocious risks. So the gap between evidence-based geroscience and this non-professional DIY biohacking is enormous. And keeping that distinction clear is key to understanding this entire landscape.
Okay, let's unpack the scientific debate right away.
Right.
The very premise of geroscience intervening in aging, it implies that aging is malleable.
It does.
But there's this deep, fierce intellectual battle at the heart of the field. You have those who see aging as a fixable, if complex, disease. And then you have those who say it's just a thermodynamic, physical inevitability, something we can't truly defeat.
And the voice of that inevitability camp is powerful. It's really encapsulated by the work of scientists like Leonard Hayflick.
Famous for the Hayflick ligand, right? The number of times a cell can divide.
The very same. His central provocative thesis is that anti-aging is an oxymoron. And his critique doesn't just rely on biology, it fundamentally rests on the laws of physics and thermodynamics.
Okay, that's a whole other level.
It is. Hayflick argues that the true root cause of aging is the intrinsic thermodynamic instability of complex biological molecules.
Let's see. It's just physics. Things fall apart. Entropy.
That's the core of it. Think about the massive complexity of a protein or a DNA strand. These are incredibly precise, three-dimensional folded structures. The universe, through the second law of thermodynamics, it just favors disorder. It favors entropy.
So it takes energy to fight that.
A massive constant amount of energy just to maintain that precise molecular fidelity. Over time, those structures simply cannot be maintained with 100% accuracy indefinitely. That escalating loss of order, the increasing randomness, that is what aging is. And from a physics perspective, it's unavoidable.
That is a fascinating way to frame it. Our bodies are basically in a constant fight with the universe itself.
Exactly, and he uses a very useful analogy to illustrate this, the car.
Okay.
A car is a complex system, and any complex system has a mean time to failure. A cheap car might be designed for, 4 or 5 years before a catastrophic failure becomes probable. For a human born today in America, that mean time to failure is about 76 years.
And something is bound to break first.
Inevitably. In any complex system, there's always a weakest link that will fail first.
Yeah.
In one car, it might be the transmission. In another, the cooling system. In a human, maybe it's the cardiovascular system or the nervous system where those age-related changes manifest the fastest. But the failure is probabilistic and ultimately certain because the system cannot maintain order forever.
And from an evolutionary standpoint, the argument is that evolution stopped caring once we reproduced.
That's absolutely correct. Natural selection is pragmatic, it's not idealistic, it strongly favors molecular fidelity only until reproductive success has been achieved.
Makes sense.
Once an organism has passed on its genes, there is effectively no survival value, no evolutionary pressure to maintain those high energy states or that perfect molecular order indefinitely.
Oh, it just lets things slide.
The resulting process is what Hayflick calls a random downward spiral of molecular disorder, which is what we perceive as aging. And this is supported historically. For 99.9% of our species' existence, human life expectancy was 25 years or less. He notes that virtually no prehistoric human remains have been found older than about 50.
Wow. So a hard biological limit seems to have always been in place. That is a profoundly challenging viewpoint. It suggests that geroscience, no matter how clever, is working against a fundamental law of physics.
It does, and Hayflick also urges us to be really precise in our language here. He stresses the need to distinguish between 4 aspects of the finitude of life that are constantly confused in popular media.
Okay, what are they?
We have to separate. Aging, that process of molecular decay. Then age-associated diseases, or AADs, the specific pathologies. Third, the determinants of longevity, so the genetic limits. And finally, death.
And the distinction is important because...
Because he emphasizes that age changes are the greatest risk factor for those diseases. But intervening in the diseases, say, curing cancer, it doesn't stop the underlying process of aging. It just ensures you live long enough to die of something else that aging makes more probable.
But here's where it gets really interesting, right? That inevitability argument is directly contrasted by the modern geroscience approach, which says that even if aging is rooted in physical law, those mechanisms are still malleable. We can intervene.
Yes. We can, at the very least, compress that period of morbidity.
And that is the modern consensus within geroscience. The aim isn't necessarily immortality.
Not at all. It's to delay, mitigate, or even prevent those common age-related medical conditions by intervening in the specific mechanisms of cellular aging. The theory is that if you treat the underlying cause aging itself, you effectively treat all age-related diseases simultaneously.
That's a much more efficient approach than playing whack-a-mole.
Exactly. Waiting for individual diseases to arise and treating them one by one. That's the old model. The goal now is truly the compression of morbidity.
So what are the specific molecular weak points that geroscience is targeting? What are these so-called hallmarks of aging?
There are a number of them, but 3 are particularly crucial in the current research landscape. The first is cellular senescence.
Okay.
So as our cells accumulate damage over time, the body has a mechanism, apoptosis or programmed cell death, that usually removes them.
A kind of cellular housekeeping.
A very important one. But as we age, apoptosis becomes less efficient, and these damaged cells, They stick around. These are the senescent cells. They're not dormant. They are metabolically active, but they can no longer divide.
And they cause trouble, I'm guessing.
They cause a lot of trouble. This is the fascinating part. They're sometimes called zombie cells
Zombie cells, I like that.
because they secrete this toxic cocktail of inflammatory molecules, growth factors, and proteases. This secretion is known as the senescence-associated secretory phenotype, or SASP.
Okay, so they're spewing out this nasty stuff.
And that SASP disrupts adjacent healthy cells. It promotes chronic, low-level inflammation throughout the body, what we now call inflammaging, and it accelerates the aging process systemically.
So a few bad apples spoil the whole bunch.
An incredibly good analogy. Research has shown that if you transplant even a small number of senescent cells into a young mouse, it causes persistent dysfunction. So the medical intervention here is something called senolytics drugs, designed specifically to clear out these toxic, non-dividing cells.
That's a very clear target. What's the second major mechanism?
The second involves the structure of our DNA, specifically the telomeres.
Right, the caps on the ends of our chromosomes.
Exactly, like the plastic tips on shoelaces. They prevent the DNA from unraveling during cell division. Every time a normal cell divides, the telomeres shorten just a little bit. When they become critically short, the cell enters senescence or apoptosis.
And that shortening leads to the classic signs of aging.
Yes, things like fatigue, muscle loss, skin thinning due to collagen depletion. Now, while this is a natural process, we found that stress hormones, particularly high levels of cortisol from chronic stress, are scientifically proven to accelerate telomere loss.
Stress literally ages you at the cellular level.
It does. So some anti-aging companies are now trying to find safe ways to activate an enzyme called telomerase.
Which rebuilds the telomeres.
It can rebuild and extend them, potentially delaying senescence. However, and this is a huge however, this intervention is fraught with risk. Uncontrolled telomerase activation is a key feature in roughly 90% of all human cancers. It's what allows them to divide indefinitely.
Wait, so the cure for one problem, telomere shortening, dramatically increases the risk of the biggest age-associated disease, cancer. That sounds like a fundamental biological conflict.
It is. That's the cancer-aging trade-off, and it's one of the deepest conflicts in biology.
So the very things that protect us when we're young hurt us when we're old.
Precisely. Many of the processes that are essential for short-term survival and preventing cancer when we're young, for example, rigorous DNA repair mechanisms, or the ability of cells to trigger senescence when DNA is heavily damaged, are the very mechanisms that contribute to aging later on.
So if you mess with one, you risk the other.
You do. If you inhibit the DNA repair response to try and make a cell younger, you greatly increase the risk of that cell surviving with damaged DNA and eventually becoming cancerous. Biology has fundamentally biased itself toward survival and reproduction now, even at the cost of indefinite lifespan later.
And what about the concept that sounds most like science fiction, actually resetting the clock on a cell?
That's the realm of cellular reprogramming, and it is truly cutting edge. The idea stems from the work on Yamanaka factors.
Right, the 4 genes that can turn an adult cell back into a stem cell.
Exactly. They can take a fully adult specialized cell, like a skin cell, and revert it backward into an induced pluripotent stem cell. These are cells that can produce any type of cell in the body. It effectively resets the aging clock back to this highly plastic, embryonic-like state.
It's like what happens in a fertilized egg.
It mimics that process, yes. The breakthrough is monumental, but the risk is profound. If you use the Yamanaka factors and turn the cell all the way back into a fully pluripotent state, you currently get the formation of teratomas.
Hold on, a teratoma, for anyone who doesn't know, what exactly is that? It sounds terrifying.
It is. It's essentially a tumor made of, well, chaotic multi-tissue growth. Since the cell has lost its specialization and reverted to a state where it can form anything, the resulting tumor might contain bone, hair, muscle, or even nerve tissue.
That's horrifying.
It's a terrifying form of cancer that shows the power and the lack of control inherent in full reprogramming. So researchers now are trying to find partial reprogramming methods, just turning the clock back a few years, not decades, to get the rejuvenation benefits without crossing that dangerous line into cancerous chaos.
It sounds less like a careful tweak and more like wielding an atomic bomb in a laboratory. But this field is moving toward clinical relevance, right?
Absolutely. The scientific community is pushing hard for regulatory changes. Trials like Tame Targeting Aging with metformin are actively recruiting to test whether existing drugs, in this case the common diabetes drug metformin, can effectively target aging processes.
So if a trial like that succeeds,
If these large-scale trials prove successful, it will be a major milestone. It would force regulators to recognize aging itself as a treatable indication, not just a fact of life. And that would unlock enormous investment and fundamentally shift the practice of medicine.
we've thoroughly dissected the intellectual debate, the tension between Hayflick's thermodynamics and geoscience's molecular targets. But the public face of this industry, the image most people have, is often so far removed from these sober, meticulous academic labs.
So far removed.
So we're now diving into the world of extreme, highly publicized biohacking, exemplified by Brian Johnson.
Brian Johnson is, without a doubt, the public icon of this extreme longevity pursuit. He's a successful tech millionaire, a venture capitalist, and he reports spending a staggering $2 million a year on his regimen, which he calls Project Blueprint.
All aimed at achieving what he says is an impossible goal: never dying.
That's his stated goal. And this level of personalized constant intervention is it's unprecedented.
And he backs it up with data, which is part of his appeal, right?
Yeah.
What are the specific markers he claims to have achieved?
He undergoes constant medical testing, tracking hundreds of biomarkers. He generates data volumes that are usually reserved for entire clinical trials. And he claims, for instance, to have the functional lung capacity of an 18-year-old, the skin of a 28-year-old, and the heart of a 37-year-old. Overall, based on various indices of biological age, like epigenetic clocks, he claims to have successfully reversed his biological age by 5.1 years. The key is that the pursuit is entirely data-driven. He treats his body like a vast, complex optimization project.
Let's get into the granular details of his daily routine, because this gives us an amazing insight into the sheer extremity of this movement.
The commitment is absolute. So start with the supplements. Johnson reports taking a whopping 91 pills each morning.
91. Every single morning.
Every single morning, with his total daily intake exceeding 50 pills if we count all sources. And these aren't just generic multivitamins. They include specific pharmaceutical agents like a carbose, a prescription drug for blood sugar.
Right, for diabetics.
Yes.
Yeah.
And hyaluronic acid for skin and joints, turmeric piperine for inflammation. I mean, the sheer logistical and financial commitment just to manage this pharmacy is immense.
And that's before food.
Before food. Then there's the diet. He adheres strictly to a vegan diet, with the only exception being collagen peptides for skin and connective tissue. He consumes a carefully monitored total of 2,250 calories per day.
All tracked, I'm sure.
Rigorously balanced. 130 grams of protein, 206 grams of carbs, 101 grams of fat. And crucially, all of his daily meals are consumed before noon, so it's an aggressive form of time-restricted feeding.
And his breakfast is that green giant drink.
Yes, a complex concoction packed with things like chlorella algae, creatine for muscle, and spermidine, which is studied for its anti-aging properties.
This truly feels less like a sustainable human lifestyle and more like, I don't know, a high-tech engineering project focused solely on the self. It must require a whole team of people to manage.
It's optimization taken to absolute extreme. Beyond diet and supplements, he uses technology constantly. He wears a red light therapy cap for 6 minutes daily to fend off baldness and stimulate hair follicles.
Does that even work?
Well, the rationale cites a study showing this type of therapy can increase hair density by nearly 40% over several months. He also uses specialized audio therapy to boost his hearing. Every single aspect of his life is quantifiable and subject to technological intervention.
Okay, but then we get to the really extreme stuff.
Yes. Then we reach the interventions that draw the most scrutiny and concern from medical professionals. These are the things that sources highlight as genuinely extreme.
Like what?
Highly invasive procedures. For instance, injecting himself with his teenage son's blood plasma.
Wow, okay.
A practice that major medical institutions have heavily cautioned against due to a complete lack of evidence. And then there's the public sharing. He publicly tracks and shares data about his own nighttime erections on social media, treating even intimate biological functions as just another data point for public analysis.
The public tracking is unsettling, but let's focus on the medical side. Despite all this obsessive, meticulous data generation, what is the critical consensus from outside experts? And what does Johnson himself admit about this process?
Well, experts consistently sound the alarm over the safety and sustainability of these radical approaches. They view Johnson, quite frankly, as a well-funded human guinea pig.
Right.
But what's most telling is Johnson's own admission. Despite the millions spent and the team of doctors, he openly admits that his team makes frequent mistakes.
He admits that.
Openly. Because they are operating in uncharted scientific territory. This just confirms the inherent risks of DIY biology, even when you have a massive budget and a data apparatus. When you're making frequent mistakes in medical procedures, the long-term risk profile is horrifying.
That immediately undercuts the image of total control he tries to project. He's risking his health on unproven procedures, and now we hear that his commercial enterprise built around this experiment is actually failing.
That's the fascinating business and philosophical subplot. Johnson's supplement and service startup, Blueprint, which was supposed to commercialize his regimen, is reportedly shutting down or being sold off because of ongoing financial losses.
So it wasn't profitable.
Apparently not. Johnson has publicly stated that the commercial ventures were a pain in the A and a costly distraction from his primary personal objective.
So the commercial viability collapsed, forcing him to shed the business. But the philosophical intent remains, maybe in an even more radical form.
Precisely. He's shifting his focus entirely away from entrepreneurship to his philosophical movement, which he calls Don't Die. He now frames the commercial stuff as just a hindrance to his deeper, almost messianic goal of fundamentally reshaping humanity's relationship with death and pursuing what he terms post-human evolution.
So he's going from biotech businessman to futurist prophet.
That's a good way to put it. However, this radical pursuit of optimization is, well, it's inextricably linked to ethical controversy, particularly concerning the environment he fostered around him.
Okay, let's get into that. The management style and the confidentiality agreements.
The sources reveal a pretty disturbing context surrounding the work environment at his companies. Employees, including medical staff, sometimes had to sign up to 3 separate compounding legal documents. And one highly unusual opt-in document required staffers to explicitly state they were comfortable with Johnson wearing little and sometimes no clothing, no underwear, and hearing discussions of sexual activities, including erections.
I'm sorry, what? That is so far beyond an unconventional workplace policy.
Right.
That speaks to a profound lack of professional boundaries.
And critically, the document went further. It required staffers to affirmatively agree that his behavior, regardless of how unusual, was not to be considered unwelcome, offensive, humiliating, hostile, triggering, unprofessional, or abusive.
So it's a preemptive waiver against any future complaints.
That's what it looks like. It's designed to indemnify him before anything even happens. Former employees, including Johnson's former fiancée, who was also an employee, have filed official complaints about these highly restrictive confidentiality agreements, or NDAs.
What were the penalties that kept these employees from speaking up?
The lawsuit filed by his former fiancée alleged that Johnson compelled her to sign an NDA that included a catastrophic potential penalty of $500,000 for breaches.
$500,000.
Yes. Media sources confirmed that employees felt tremendous pressure and fear of financial ruin, which effectively silenced them. The company, in its defense, claimed these aggressive NDAs were necessary for establishing clear boundaries and expectations.
But when trust is enforced with $500,000 penalties and waivers about nudity, that sounds less like a quest for human longevity and more like a bizarre, ethically compromised cult of personality.
It certainly raises serious questions.
That context just completely reframes the narrative. You see this contrast between the peak of technological optimization, a man trying to achieve perfect data, and this ethical nadir of human resource management. It really highlights the dangers of radical individualism operating in a highly unregulated, high-stakes environment.
Yeah.
And this naturally transitions us because we move now from the individual celebrity to the commercial structure that allows these extremes to flourish. This field is a gold rush, but the ethical and commercial structures are just as important as the science. Who exactly is mining the gold here?
This brings us to a critical analytical construct detailed in the sources. The toxic expert.
Okay, what is a toxic expert?
These are not just well-meaning but flawed professionals. They are defined as individuals who systematically engage in professional and intellectual vices, deliberately exploiting public trust by disseminating claims, often unsubstantiated, misleading, or outright harmful for their personal and commercial gain.
All while keeping up an appearance of legitimacy.
Exactly. They are highly skilled at that boundary work.
And these toxic experts, you argue, aren't just isolated bad apples, they're products of a larger system.
Precisely. The environment that fertilizes this kind of expertise is deeply structural. Since the late 20th century, we've seen the widespread expansion of neoliberalism.
The economic and political ideology.
Yes, rooted in thinkers like Friedrich Hayek and Milton Friedman. It favors maximal free markets, deregulation, and minimal government intervention, especially in social welfare.
And how does that connect to healthcare?
Crucially, neoliberal policies have catalyzed the transition of healthcare from a public welfare, right into a marketized consumer good, when health is a product to be purchased. When optimization is a luxury service, not a societal standard, it creates fertile ground.
So the lack of regulation and the presence of huge amounts of capital.
It means that experts with questionable claims can gain public legitimacy and exploit the consumer's hope and fear of aging for massive commercial gain. The system incentivizes the sale of hope, even if the product is largely unsubstantiated.
And a lot of that legitimacy hinges on credentials, right? Titles and language that can easily be misinterpreted by a consumer who's desperate for a solution.
That is the core mechanism of the toxic expert. We can look at the specific example of Oliver Zolman, who works closely with the longevity community and brands himself publicly as Oliver Zolman, MD.
Okay, the MD carries a lot of weight.
Immense weight, especially in the U.S., where it universally means a doctor of medicine licensed to practice. However, Zolman earned his medical degree in the UK, where the MD is often a higher research degree, kind of like a PhD, taken after the primary medical qualification.
So it's not the same thing.
It's not. But the crucial distinction goes beyond that. A search of the UK General Medical Council Register, which was verified by the source material's authors in July 2025, confirmed that Zolman is not licensed to practice medicine in the UK.
Wow. So he has the academic credential, but not the clinical license.
Exactly. And that distinction is completely lost on the public, leading to a significant and frankly dangerous misperception of his clinical qualifications and authority when he dispenses advice.
So the language and the titles are used to blur the line between genuine licensed medical practice and this unregulated commercial biohacking.
That's right. And the sources draw a very strong line here. Biohacking is explicitly defined as non-professional, lacking scientific evidence, and carrying those atrocious risks we mentioned, especially when it involves invasive procedures like self-made plasma injections.
Okay. And how are the more organized medical anti-aging clinics different?
Well, they claim to operate with convincing data. They often focus on reducing morbidity and mortality through proven lifestyle and diet techniques, which they then equate with anti-aging properties. Theoretically, they should be aligned with the aims of geroscience, but they often use these aggressive, market-driven tactics.
And this friction doesn't just exist between biohackers and doctors.
Yeah.
It's at the institutional level, right? Between established gerontology and the advocates of anti-aging medicine.
Well, the relationship between those two is historically acrimonious. Organizations like the American Academy of Anti-Aging Medicine, or A4M, actively engaged in aggressive boundary work against the entire mainstream gerontology community. They had to discredit the traditional view to establish their own legitimacy.
And they use some pretty strong language to do it.
They famously derided traditional gerontology as the death cult of gerontology.
A death cult.
Yes, arguing that mainstream scientists sustained the outmoded stance that aging is natural and inevitable because the status quo was required for their grant funding and institutional power. This aggressive language was designed to position A4M members as radical, brave innovators challenging a complacent establishment.
And how else did they promote themselves as superior to traditional doctors?
They aggressively marketed their members as the definitive go-to experts for specialized treatments, particularly focusing on hormone replacement therapies. Their promotional materials argued that most traditional endocrinologists, the actual specialists in hormones, lack interest and expertise in treating subtle hormone deficiencies.
So they claimed they were the only ones who could help.
They positioned their members as the only true source of relief through adequate hormone treatment. But here's the critical point of contradiction. Despite this radical promotional strategy, interviews with these anti-aging practitioners themselves reveal that their ultimate goals were largely in line with the mainstream view of successful aging.
So they were focused on preventing disease, maintaining function, not living forever.
Exactly. Not literally achieving biological immortality. So the real conflict, it seems, lies not in the goal-improving health span, but in the questionable means and the aggressive, sometimes misleading promotional strategies used to capitalize on the public's desire for quick fixes.
This brings us to the most important part of this deep dive, the real evidence-based path to longevity. If the extreme million-dollar protocols are risky and ethically fraught, and if even the anti-aging organizations agree with the mainstream goal, where should you, the listener, focus your limited time and money?
The central, unwavering finding from decades of public health research is clear. Longevity should be about adding life to years, not just years to life. We have to maintain a laser focus on health span.
Right.
The problem is that while overall life expectancy has increased, healthy life expectancy, the years we spend free from chronic disease, has not kept pace. This results in longer periods of suffering and poor health in later life. The goal of geroscience and any responsible health policy must be the compression of morbidity.
Shrinking that window of poor health as close to the end of life as possible.
Exactly.
So what are the proven hacks that don't require $2 million a year, a full-time staff, or a red light cap?
The largest and most dependable benefits come from what we might call old-fashioned prevention. It's the simple, though often difficult to adhere to, motto. Eat healthier, move more, smoke and drink less, and prioritize strong social ties.
The basics.
They are the foundational support structure for all biological optimization, and population studies have provided overwhelming statistical proof of their power. Large studies show that improved behavior in just those 4 key areas, exercise, not smoking, moderate alcohol, and high fruit vegetable consumption, has an astonishing combined impact on reducing mortality.
Far more than any single supplement on the market.
Far more. These 4 habits can collectively add years of high-quality life.
It's easy to focus on the physical stuff, diet and movement. But you highlighted the crucial impact of mental well-being on measurable biological processes.
That's a massive factor that gets overlooked in the rush for biomarkers and expensive pills. Stress management has a direct, measurable biological impact on cellular aging.
How so?
In modern life, many of us exist in this chronic, low-level state of fight or flight, that constant deluge of stress hormones, particularly cortisol. It's scientifically proven to accelerate the shortening of telomere.
The protective caps.
Those protective caps we talked about. Chronic stress physically speeds up cellular aging. Therefore, learning to effectively regulate that stress, whether through breathwork, meditation, or just stepping away from screens, has a profound impact.
And mental resilience. Social connection.
Equally powerful determinants. Reflection, humor, strong social bonds. These psychological elements are free, they're highly effective, and they are fundamentally accessible.
And even the self-identified pioneers of biohacking, who market this stuff heavily, they caution against the extremes, right?
They do, which is a great validation for the simpler path. Even Dave Asprey, who's often credited with popularizing the term biohacking, counsels caution. He's a huge proponent of intermittent fasting, for example, but he warns listeners that trying to adhere too strictly can actually break your metabolism. He emphasizes that the dangerous mentality of more is better does not apply here.
That's interesting.
He also cautions against what he calls superfood confusion. He notes that many buzzy ingredients that no one had heard of 10 years ago are suddenly marketed with these hyperbolic claims. His argument is, if they were truly that superior, they would have been top-tier staples in centuries-old traditional systems like Chinese medicine or Ayurveda. So his advice is simple. Don't blindly trust a label. Base your decisions on robust evidence.
This brings us to the critical ethical and societal challenge that underlies this whole field. The equity crisis. If the proven keys to a longer, healthier life are simple diet, exercise, connection, why is the average healthy life expectancy gap between the richest and poorest regions in a country like the UK up to 20 years?
Right.
Why is it that the free interventions are so difficult for so many people to access?
This is the crux of the moral and structural issue, and it's the challenge for policymakers and for society as a whole. If and when these sophisticated geroscience-derived life extension measures become commercially viable, they will, by default, primarily benefit the wealthy, which will just exponentially increase existing health disparities. And the profound irony, which is almost cruel, is that the most basic evidence-based longevity practices, good diet, consistent exercise, sufficient sleep, are structurally the hardest for people in poverty to maintain.
Because they're working multiple jobs, have no time, live in food deserts.
Exactly. They lack safe green spaces, they struggle with time for rest or meal prep. These are the social determinants of health.
So the issue isn't a lack of personal discipline, it's a structural barrier to health itself.
Precisely. We cannot solve this problem with high-tech, individualized fixes aimed at billionaires. Addressing these profound inequalities requires large-scale structural solutions. Policy efforts have to pivot away from just focusing on individual consumer choice and toward closing that 20-year gap.
Which means things like affordable housing, low pollution, integrated health and social care.
Yes. We have to stop treating aging as a niche concern for the wealthy elite seeking immortality. We have to recognize that the massive disparities in how we age reflect fundamental social and economic inequities.
So what does this all mean for you, the person listening right now, trying to make sense of this longevity gold rush? We've journeyed from the inevitability of thermodynamics, the universe slowly winning, to the meticulous, occasionally hazardous, multi-million-dollar routines of tech pioneers who openly admit to making frequent mistakes.
Hmm.
We've examined the legitimate scientific quest, geroscience, which seeks to compress morbidity, the time we spend suffering, and we've contrasted it with the low-cost, evidence-based lifestyle changes that are accessible to all. The tension remains fierce. It's between the market-driven, individualized pursuit of lifespan extension for the few and the fundamental public health goal of living well longer for everyone.
And the science itself, when you look beneath all the hype, it tells us that the simple things are the most effective.
Movement, connection, proper diet.
And that leads us to the final provocative thought that we want you to mull over as you conclude this deep dive. We see these powerful tech billionaires actively shutting down their commercial, profit-driven ventures, claiming they are distractions, in order to pursue a radical philosophical don't die movement. They're rejecting the capitalist route to chase a deeply individualized, expensive path to indefinite lifespan.
Right.
Yet, at the very same time, the scientific community emphasizes with overwhelming evidence that the true proven keys to maximizing health span are simple, affordable, and fundamentally ethical movement, connection, diet, stress management.
But those simple keys remain structurally inaccessible to the majority of the population.
Exactly, because of socioeconomic barriers, precarious employment, lack of affordable resources.
So here's the question we want to leave you with.
The question is this. If the most effective and proven methods of maximizing health span are simple, affordable, and fundamentally ethical, why does our society continue to dedicate massive amounts of capital, media attention, and expert energy to the extreme, personalized, and financially risky quest for lifespan extension for the few, instead of investing in the large-scale structural changes that would raise the health baseline and compress morbidity for everyone?